All right, guys, so let's look at some Chapter 8 stuff. So we're going to take another little detour here, and we're going to look at polar coordinates. So we've done a ton of stuff in rectangular. We also have this thing known as polar coordinates, and it's going to kind of set up what we're going to do a lot of the second half of this course. I'd encourage you, if you get some time, do check out the polar coordinate Wikipedia page. It's got a lot of good stuff for what we're doing, obviously, but it'll show some applications. They're using this stuff first millennium BCE, Greeks, of course, and kind of talks about the little history here. It talks about the conversion, like we're going to look at here. What you can do in polar is you can create these really unique graphs that you can't really in rectangular. Okay, so here's a circle. We can do that in rectangular. We can do it in polar, but the equation's so much easier. Here's a rose flower. Okay, rectangular is super tough. That's it. 2 sine of 4 theta. If you're in polar coordinates, 2 sine 4 theta graphs this. You can do Archimedean spirals. These things here, we're going to use them when we get into ellipses and whatnot. So if you get a chance, check that out. You can get in some differential equations here. You guys that are going to be looking at calculus, integration, how we measure stuff and whatnot. So a lot of good stuff there. Okay, so first we're going to start with some terminology. So rectangular, you guys know we're going to take an x-axis, we're going to take a y-axis. Okay, that's no big deal there. Polar, here's what we do. We let the origin be the pole. Okay, so it's just a new name for something we've had. Now the x-axis is called the polar axis. So things usually start on the x, they're now going to start on the polar axis. Here's what happens. You have the polar axis, we're going to tilt this guy up some theta. You have some radius, okay? The point's going to be right here. We're going to write it as r comma theta. So it's no longer x comma y, it's now r comma theta. Okay, the radius can be positive, it can be negative, and obviously our angle can be anything from 0 to 2 pi, and then also the multiples of those as well. So if you want to think about it, what you're really doing is you're taking this guy, you're matching those up, and you're graphing something like that. Okay, so there is some connections between these. Now, if I ask you guys to graph 2, 8 here, we want to look at comparing rectangular versus polar. So we said rectangulars are x, y's. 2, 8, you'd go over 2, you'd go up 8, you'd plot a point. Okay? If it's in polar form, it's going to look like this. 4 comma pi over 6. Anytime you see something in polar form, it's an r comma theta. So when I look at this, you got to think about what's my r, what's my theta. I'm going a radius of 4 in a pi over 6 direction. So these don't have to be exact, but of course they got to be in the right quadrant. So we're going to start at the pole here. You get your polar axis coming out this way. We want to tilt this guy up pi over 6. We want to go out a distance of 4. So eventually we'll do things where we will plot these at 4, just making them appropriate length and label them correctly. So if I wanted to graph, let's say 3 comma pi over 6, it'd be on the same line, it'd just be right there. A 2 would be right there, 1 would be right there, and so on. Okay, 5 would be out here, 6 would be out there. We just adjust the radius. Now, what if I give you a negative radius? This is where it gets a little bit tricky. So we're going to plot r theta, but the r is going to be negative in this case. Okay, so I'm still going to tilt up theta like I have before, wherever my theta ends. Now a positive radius would be on this blue line, but if I'm plotting a negative radius, it kicks exactly 180 degrees opposite of it. So for example, let's say this point right here is 7 comma, oh, I don't know, let's do pi over 4. That's that guy right here. This guy down here would be something like negative 7 pi over 4. So when you see that negative r, kick it 180 degrees opposite. Okay, the angle stays the same. We have this angle going here. Then negative r is going to go completely opposite. Okay, and that is a little bit tricky at first. So if I ask you to graph negative 4, 7 pi over 6, okay, here's what's going to happen. You're going to look at this and go, this is an r comma theta. I need to go 7 pi over 6. So 7 pi over 6 will take you into quadrant 3. If it was a positive r, your point would fall on this line. Because it's a negative r, it bounces 180 degrees opposite of it, and it comes up here. Okay? So that negative 4 pi over 7 pi over 6 is actually this guy right here. Now you may be wondering, why would we want to plot these when it's negative, when I can say that point right there is the same thing as a positive 4 and just a single pi over 6, like we have right here. Because pi over 6 and 7 pi over 6 are separated by exactly 6 pi over 6, which is 1 pi. So you can, so there's all kinds of different conversions in between these things. Okay. Now, here's kind of a general formula if you want to remember these things. So a point with polar coordinates r theta can also be represented by the following this. So r comma theta plus 2 pi k. Here's what that means. Let's pick something easy to model this. 2 comma pi over 3. So I'm going to tilt up pi over 3, and I'm going to put a 2 right there. Well, couldn't I have gone around 360 first and then tilted up pi over 3? That's all this is saying right here. So it's saying 2 comma pi over 3 is the exact same thing as doing 2 comma pi over 3 plus 6 pi over 3. Because remember that it's just 2 pi. So this is the exact same thing as this. We could add another 6 pi and another 6 pi and etc. and on and on and on. Now when you look at this other one, when you have the negative radius, we have to take the theta. We first have to add pi and then add another 2 pi. So what that means is if we looked at negative 2 pi over 3, we'd tilt this guy up pi over 3, we'd go to plot a 2, we'd recognize it's negative, so we kick it down this way. Now if I want to get this guy to match up with this guy, I got to add a pi first. So I got to add a pi from this blue one to get back to here, and then I can start kicking these guys all around by 2 pi's again. All right? So really it's just a matter of practicing adjusting things accordingly. Because if you're good with the general formulas, worry about that. If you like drawing pictures and just trying to figure stuff out, worry about those. Okay? To finish part 1 off here, I'm going to give you guys 3 little examples. I'm not going to talk you through them a ton. I'm going to see if you guys can come up with these. Now, we want 2 pi over 3, so I know I've seen that number before. That's probably why that came to my head. Still good practice, but I'm changing these up for you. So you may have to adjust your k's, make them negative, make them positive 1, positive 2, whatnot, to get them in those certain ranges. Here's all your answers down here. So pause this guy as long as you need to before you start part 2, and try these and come with questions tomorrow on those guys if you're not able to get them. Okay, we'll see you guys in part 2.